Okay, so hello everyone. Thank you so much for joining us this morning for the ZEOS Dissemination Workshop. We are super excited to talk about our collaboration with the Safe Seaweed Coalition. So without further ado, let's jump right into it. So this workshop has been organized in collaboration with the Safe Seaweed Coalition, along with the ongoing support and interest from Nestle. The project's main objective is to pave the road for seaweed packaging towards commercialization, with a focus on legal and regulatory aspects. Thus, we organized this workshop to showcase the results of the project and talk to you about ZEOS, of course, and our ongoing developments. And at the end of this workshop, we will have a Q&A session, so please feel free to put all of your questions in the chat and we will answer them at the end. So here's a little agenda for today. So we will begin with our founder Guy, who will talk about ZEOS and our commitment to scalability and sustainable solutions. And then we will have Adriana talking about regulations and legislation. And then we will have Camila talking about sustainability and our ongoing projects. And we will finish off with the Q&A session. All right, so to begin, I am happy to introduce to you our founder and CEO, Guy Maurice. He has a background in waste management and extensive experience within the field of sustainable packaging and the world of seaweed. And he is going to talk to you today about the genesis of ZEOS and the commitment to sustainable and scalable packaging. Take it away, Guy.
Yeah, thank you, Kela, for the introduction. Thank you, everyone, for being there. Hello. I can recognize some names and faces. So I'm happy to share some part of our journey today, but also like many of us attending today, we all have a story with seaweed, and many of us believe actually in unlocking the power of seaweed in various ways. Still, we really need to remind ourselves as well that it's not because we use seaweed that our derived product is suddenly sustainable, and that is actually what we will try to showcase today. So I will shortly explain a bit more about how it started with ZEOS. So for many years, basically, I have been dedicating my time to a global environment project across the world, in EU, mostly Africa and South America. And basically, after working in the renewable sectors, so at Equinor, so it's a state-owned, basically oil and gas industry in Norway. So I took a sabbatical year, and that was back in 2016, which is some time from now, and decided actually to provide my services and knowledge really in waste management to local governmental groups in Panama. And however, well, very fast, I could see that all the effort that was made were a bit useless, since at the end, everything that ended in the landfill was actually burned by scavengers, which is something that we see across the whole world, actually, in many countries, which had actually a direct contamination to its surrounding. And then to top up my frustration, on a layover in New York before heading back to Norway from Panama, I was served an organic drink with a plastic straw. And that was my first reaction, was to ask actually in a funny way to my wife to say, why don't we eat this damn straw, sorry for the vocabulary, but there was actually my first idea on developing an edible straw that came. And basically the idea was tackling the problem rather upstream, so more the industry, rather than the downstream, the consumer, where maybe we have less impact. So, and to use the use of sustainable and compostable material actually started to become a bit of my mission. Yes, next slide. And by digging also further, and deeper into the problem, I realized that on the top of the problem of the end of life generated by petroleum-based plastic, but as well actually by certain, and you're all aware about bioplastic, the regulation was actually starting to limit its use in certain applications. And also that the cost of the raw material, as you all seen, and even more in the last few years, and how was actually increasing highly for those material. And the lack of viable, sustainable alternative made it actually also finally a business opportunity with a big market opportunity. And having lived in Norway, well, you know, seaweed came quite as a logical biomass to look at for the creation of a novel sustainable alternative to plastic, and also keeping in mind the large volume potential, but as well the fact that the biomass does not compete with land in opposition to many current alternatives, and that's Camilla will more talk about that. And also another point was actually the social aspect, and therefore to look for a solution that would actually not disrupt the whole industry, and then to put at risk many jobs in many regions of the world, knowing that the manufacturing is not only in European or countries, but it's actually quite wide. And yes, next slide. And actually, with years with in-house development, our team ZEOS that had actually created a seaweed-based pellet that can actually be transformed into final product using conventional machinery. So that means used already in the packaging industry. And our pellet can be used to make film, like a rigid part, and also coating for paper-based material. And in the next slide, yeah, you see some pictures of some of the prototype we produced over the years. So you can have an idea of the scope of user cases. So as I mentioned, it goes from flexible material, and that can be used, for instance, for windows and pasta or food boxes, or as well sachet for dry ingredient, also to semi-rigid, and we can use it for producing a coffee capsule or glasses, and finally as well that we can use it as a coating on paper, and that can be used for, I mean, there's multiple applications that can be a greasy product such as the burgers wrappers, for instance. And I would also talk a bit more about the team, because all that has been possible to the whole team. And so we have a wide range of expertise that goes from material science, like product development, business communication, waste management. And basically where ZEOS is located, we have actually our product development lab facilities that are in Spain, Barcelona, which is quite attractive for many interns. As you can imagine, also seaweed partners in Norway, but we're not limited, obviously, to seaweed in Norway, but we worked a lot with many farmers and biorefinery as well in that. And also we have our headquarters of the company that is based in Switzerland, since we are collaborating with multiple brand owner and manufacturers that are around Switzerland and in Switzerland. So yeah, and finally, what makes us as well a bit more different from others is that we collaborate closely with industry to develop marketable material. And so we work both with manufacturing companies on one side and brand owners, retailers on the other side, to make certain that the product that gets to the market has a value. So, and with manufacturing company, we identify the processing technologies they use, and also what type actually of product they are looking for. And we de-risk pilots with them by doing processing trials, and that's with tech transfer centers and R&D pilot lines. Yes.
Great, thank you for that, Guy. So now I'd like to introduce to you guys Adriana Kivik. She is the co-founder and CTO at ZEOS. Adriana has a background in chemical engineering and biotechnology, and she also has a PhD in material science. Adriana, I don't think we can hear you. All right.
Now?
Yes,
Okay.
we can hear you now.
Sorry, I had to plug and unplug my headphones.
No worries.
Yeah, before going a bit deeper into regulations and legislations, I want to make sure you understand where we lie within the value chain. So we rely on external partners for the supply of the seaweed biomass. We don't do any cultivation of or harvesting ourselves of the seaweed biomass, but we have expertise in material formulation optimization, material compounding, and also manufacturing. So we supply in the format of pellets or final products to brand owners, retailers, or converters. And just a bit more on our expertise and a bit more on the edge in terms of competitiveness concerning our materials. So we're using naturally derived biopolymers from seaweed biomass. And this means that we're compliant with the SUPD. So our materials are not considered as plastic for single-use applications. I will further comment on this in the next slide. We also are using plug-and-play solutions. So our seaweed-based pellets can be used in conventional processes used already by the industry for processing fossil-based polymers. And we use a green manufacturing process, meaning we use no toxic chemicals in our processing of our materials, and we use low energy consumption processes. And Camila will talk further about this. So considering the regulation of the SUPD, most of you are surely familiar with this. The materials that are using covalently modified polymers are considered as plastic for single-use applications. In our case, we have done an assessment together with the consulting firm and packaging law firm, Keller and Heckman, which has expertise in the field. And the assessment has shown that our product, we have shared, of course, the formulation, the technical data sheet, and of course, composition of our materials, which are mostly based on seaweed, plus fillers and additives and plasticizers. But basically, our product does not fall under the SUPD because, as mentioned before, we're using naturally derived polymers coming from seaweed, which have not been chemically modified. So I think this is something quite interesting, since within the market, there's many alternatives already, but many of those are being banned for single-use applications. And in the next slide, we can see kind of within the competitive landscape of materials out in the market already. Of course, fossil-based plastics such as LDPE and PP are being banned because of their origin, but also fermentation-derived polymers such as PP, PLA, or chemically modified polymers, even though it's cellulose or bio-based such as cellulose acetate, are being banned for single-use applications. That leaves us with paper-based materials, starch-based materials, or cellulose-based materials, which have not been chemically modified. And as well, potentially also, of course, seaweed-based materials. So a bit more on the European legislation on sustainable packaging. This has been done within the framework of the SEAPACK, or the SEAPACK project. And we have done this together with ITENE, which is a technology institute specialized on packaging, transportation, and logistics. Just a disclaimer, ZEOS or ourselves are not experts in legislations and regulations. This has done together with them, and we're presenting just the kind of findings of the report that they have made for us within the context of this project. So things that we have to take into account when developing novel sustainable packaging materials would be the first action plan for circular economy, which says that the Commission is promoting the efficient use of bio-based resources for the support of the innovation in the bioeconomy system. Basically, we have to also take into account the waste directive, looking into certifications and labeling for the appropriate end of life of these type of materials, especially when we're talking about home compostable materials, and also understanding the collection system, also the packaging directive, which interestingly states that any home compostable material can be included in target recycling rates. And the proposal on green claims, which has been submitted for evaluation to the Commission, and will be also very interesting in terms of labeling of these type of novel materials, especially related to compostability claims. Also important is the new circular plan, the policy framework for bio-based, biodegradable, and compostable materials. Probably many of you are well aware of this, which is kind of stating how Europe is looking into the plastic waste crisis, mainly focused on recyclability, but there's also space for bio-based materials or bioplastics. So very importantly, it's important to understand or to state which type of biomass is used. Bio-based plastic must be sustainably sourced. So the sourcing is of extreme relevance. Also, there is a statement on biodegradable plastic must be approached with caution. The most important thing here is that any sustainability claim has to be backed up by evidence, basically. So quantification of sustainability claims is of extreme relevance. And also there's a mention on industrial compostable plastics. Also environmental benefits have to be proven, basically. And there's also a list of applications where industrially compostable plastics are deemed to be accepted for. Also in terms of regulations and legal status for food contact materials. So when we're looking into packagings that are used within the food sector, there's two horizontal regulations that are important to just mention. The number 1935, of course, Article 16 and 17, Declaration of Compliance and Traceability, are a must for getting marketable products in the market, and also Regulation 2023 on GMP, so good manufacturing practices, related to all the steps to be able to produce the final materials to be in contact with food, and assuring that there's a quality assessment and of course certification in terms of how these are produced and with which machines is also needed to get these type of materials in the market. Also very important for food contact applications is migration test and NEAS kind of clearance, so non-intentionally added substances. So these type of tests have to be done by certified labs in order to also assess for which food categories these materials can be used for. And we have done food migration test and NEAS evaluation within the context of this project. So just so you have an understanding for those that don't know how these type of food migration tests are done, basically there's different food stimulants used in order to evaluate the food group or food stimulant that's stated here, depending on what target you have, basically. So in our case, we have done an evaluation and we see that our materials can be used for food stimulant. Kela, next slide. D2 and E, basically. D2 represents foods that have a lipophilic or greasy surface, so greasy foods, meaning, for example, chocolate, nuts, and others. And E covers all dry foods. And there's a whole list within the article, the European article, stating as well the specific food groups that the different food stimulants represent. These are just some examples. So you can see from starches, sugars, fruits, cheeses, coffee, and others would be categorized within D2 and E.
Thank you so much for that, Adriana. And so now we're going to be talking about sustainability at ZEOS, and we will have our co-founder Camila Dore, who will talk about that. And she has a background in mechanical and nanotechnology engineering, and as well as a PhD in material science. So off to you, Camila. Camila?
Now?
We can hear you.
Same problem as before. Yeah, thanks for the introduction. And yeah, I will go a bit through the sustainability aspect of seaweed-based bioplastic. As Guy was mentioned, seaweed is a huge potential that can be considered the next generation biomass. In particular, compared to land-based material, seaweed do not compete with land use, so do not require the use of land that can be instead dedicated for food crops, but also do not require fresh water or pesticides to grow. Seaweed is also extremely efficient at carbon capturing while it grows, and has a huge scale up for a huge potential for scale up. Next slide. Indeed, seaweed can be feedstock can be obtained by different sources. In particular, considering the European panorama, most of seaweed come from harvesting, but cultivation, it's a growing industry. It has a huge potential for large-scale production. Indeed, seaweed can be cultivated close to the shore, but also offshore. There are also invasive species such as sargassum that some of you might already be familiar with like are characterized by this huge blooms that produce a large amount of biomass that it's completely a waste. So the idea is that by combining all these sources, and especially by using also waste stream and side stream from higher value applications such as farm and cosmetic or food and feed, which are the main application that seaweed has at the moment, especially harvested and cultivated seaweed in Europe. So by combining all those feedstock sources, it can be obtain a relevant amount of biomass for the production of lower application products such as bioplastic and bio. Another important aspect of seaweed that's also differentiated from most of course, from petroleum-based material, but also for some of the bio-based material that are currently available on the market, is that seaweed-based material are truly biodegradable. Here you can see a test that we've done in our lab for soil disintegration. And of course, by the comparison with low-density polyethylene film, you can see that just after 36 days, the seaweed film is almost completely disappeared. And it basically gets rotten as it was food rather than a plastic material. We have also run life cycle assessment analysis. I won't go much in detail of the result, but I will be happy to answer questions. Some will arise. But with this preliminary test, we have considered basically two different scenarios, both incineration and composting as end of life. And for both scenarios, we basically achieve carbon equivalent for our material produced at laboratory scale, which is already comparable with the carbon equivalent that are produced for manufacturing on PLA or low-density polyethylene at industrial scale. So extremely promising results also in terms of life cycle assessment. Yeah, I will go now briefly on an overview of the project we are currently working on. So we are tackling development of our material from different perspectives, both for improvement of formulation, mostly to improve the barrier properties, so to enhance the water vapor barrier and oxygen barrier. This is sponsored mostly by the Norwegian government through the SEAPACK project, where we are basically working on formulation using high-end and tailored fillers and additives to improve the final properties of our flexible film and coatings. We are also working on further development of the large-scale manufacturing. This is sponsored by the European Union with the SEAPACK Eurostar project, where we are basically testing the processability of our material using conventional plastic manufacturing machine and processes at large scale for application in the food sector. And finally, we are also working with final application close with brand owner and retailer through Green Platform, which is sponsored by the Norwegian government. And also, thanks to all these projects, we have been capable to arrive where we are now and to develop all and test and prove that our material can be processed to several different conventional manufacturing process, and then we have been capable to develop product using large-scale manufacturing machines. Here you can see some application for some examples. For instance, we have the production of filament that can be cut into pellets, and we have been capable to produce film using both cast extrusion and blown extrusions, but also we have been able to produce rigid and semi-rigid items such as thermoformer trays and injected molded part like the cup you can see in the bottom right. With this, I conclude and I leave the room for the Q&A session and happy to answer any doubt or question from the audience.
Thank you so much for that, Camila. All right, so that concludes our presentation today, and I'm going to open the floor up now for questions. So I see that a good amount of you have put some in the chat. So I will pretty much go in order. So I will start with Volodymyr. Sorry if I didn't pronounce that right. So you asked about barrier properties. Would you like to go in more detail about your question?
Yes, barrier properties for fumes.
Okay.
Yeah.
Oh, sorry.
I can answer that. So I see that you asked about OTR, WVTR. So in terms of the films, we have around oxygen transmission rate comparable to cellophane, around 10 cc meter square per day. And WVTR, we're working on that. We have achieved around 100 grams per square meter. But this is also something that is work in progress. As Camila mentioned, we have different R&D projects that are focused on enhancing this, so lowering this value to something that is more competitive and similar to cellophane.
Okay, thank you. Thank you.
Great. Okay, so then the next question we have from John, and he is asking if our processes are suitable for injection molding, blow molding, and if any research on stability and permeability for OTR and MVTR.
Yeah, maybe I can. Well, regarding processing, yes, we have tested mostly any main conversion process that can be used for plastic, and we successfully managed to do injected molded part and thermoformer part, and also to cast extruded film. So the answer of that is yes, and maybe OTR and WVTR, Adriana already answered to this part of the question.
Okay, great. Next we have from Hiwei, and he is asking, how do you prevent or eliminate contamination from metals and or microplastics on our raw materials?
Yeah, that's a good question. So basically by selecting where we source the material, since we are not doing any cultivation or harvesting ourselves, we do have very close partnerships with seaweed cultivators and also harvesters in different parts of the world. So making sure that what we're sourcing complies in terms of heavy metals and as well in terms of quality is the way how we are envisioning it. We might have a previous step on quality kind of control before using it in our materials, but yeah, basically relying on partners that can provide us with the quality of seaweed that we need for the development of our materials.
Great. Next we have Philippe, who is asking about the shelf life of our finished product.
Yeah, I can also answer to that. So it will depend on the food item that you want to preserve, basically. Shelf life of our materials, we've had samples in the lab for over years. So it will depend, of course, on storage conditions, on transportation conditions. Indeed, for these type of materials, relative humidity is an issue if it's very high. But for what we have seen with a relative humidity around 50% or even higher, there's not an issue when storing or when having our materials in a shelf kind of life status. But of course, this is some of the things we're doing in ongoing projects when targeting specific applications. So for example, if we're targeting fresh fruit, fresh berries, there has to be a shelf life assessment with that type of product. Yeah.
Great. Next, we have Rohit, and they're asking, global production of offshore seaweed is roughly static in the last few years, so where will new crops come from? Camila, I don't think I can hear you.
No?
Yes.
I see there is somebody already answering the chat.
Okay.
Answer. UAE has ambition to increase algae, micro and microalgae production by 3,000% in the next decade. So I do believe like it's already the trend of seaweed cultivation in Europe. It's growing a lot, and I think there will be more and more cultivation. Now, of course, the onshore or offshore will be will depend on several factors, but the overall amount of seaweed produced in Europe is growing exponentially.
Great. And now I see, Thibault, you have a few questions in the chat. If you, excuse me, if you want to jump in and just ask your questions, this is kind of, there's a few.
Oh, hello.
Hi.
Can you hear me well? All right.
Yes.
Yeah, thanks for this great little presentation. Congrats on all the achievements, of course. Just a follow-up question for the barrier properties, whether your WVTR is measured with 23 degrees, 50% room humidity, or if you're doing the testing in tropical conditions, because I'm seeing everyone shifting to tropical just because someone will ask at some point, so you might as well test in the worst conditions.
We have done both tests. So what I've shared in terms of values is at 50%, but we've also assessing 90%.
Right. And the second question I had is, when you do this blown film, is the matrix, like the polymeric matrix, simply alginate or seaweed based? Or for processability, do you add something like PLA, PHA, PBS, PBAT, or something like this?
For the blown extrusion, we mix with other polymer. We have done just one test, and we have tested for mixing just to be sure there was something coming out from the machine.
Makes sense.
And yeah, in that case, it's mixed with other small amount of other bio-based polymers.
Okay.
Thanks. Next, we have Gabriel, if you would like to jump in and ask your questions. You have a few as well.
Assuming it's me. Hey, hello everyone.
Hi.
Thank you again for the presentation. Yeah, so my question is more for the side of alginates. If you have parameters to quantify or evaluate the quality of your alginates, if you have, for example, mg ratios, and if you have some preference for the quality of your alginate. That's it. Thank you, guys.
Camila, we can't hear you again.
Sorry. We just European project called Plasticity. There will be a publication coming soon on that, and we are working closely with our biorefinery partner on systematically study the effect of mg ratio and molecular length or of the alginate, and also using different parts of the seaweed and different species. So there will be a paper coming out in the months. Generally, of course, the property changed by changing the mg ratio, but also keep in mind that plastic, it's a very general material that can be used for several applications, and each application requires different properties. So I won't tell that there is one type of alginate that is better than others, or one specific characteristic that is desirable. But I can tell that depending on the type of application you want, you might select one or another species or one specific biorefinery process and a molecular length compared to others. Hope I reply to the question.
Okay, thanks, Camila. Next, we have Casey. Casey, do you want to jump in and ask your question about our sargassum collection?
Yes, can you hear me?
Yes.
Excellent. I'm in South Padre Island, which is the coastal bend area in Texas, the Gulf Coast region. I know that sargassums have been an issue here in the past, and the collection of that I think is amazing to be used for something good. How is that collection happening in the immediate future? Because I know that this is something that's currently in the ocean and working its way to the beaches as we speak.
Sorry.
Yeah, so I can answer that. Basically, we partner up with companies that do the collection system of sargassum, that do the pre-processing, and we receive the biomass. Basically, there is a company in Norway working in the Caribbean that is also developing technologies to do the collection of this type of biomass in order to prevent it from, rotting on the beaches, basically. So we do a lot of collaborations and partnerships since we cannot take the whole value chain, but we do believe sargassum biomass can be used for packaging applications.
Okay, great. So next question is from Dario. I can actually answer this. So where is our R&D lab located? And we are located in Barcelona. Please let me know if you have any further questions, Dario. Okay, if not, then we'll move on to Nadia. Nadia, would you like to hop in and ask your question?
Hi, sorry.
No worries.
Yeah, I was just curious which specific seaweeds you use or any kelps. I'm based in South Africa, and our species of kelp, Beconia maxima, has got a lot of potential. Just want to find out if there's a possibility of testing other species than the ones you're using at the moment.
Yeah, we are also always very interested in testing different species also, because as we mentioned in the presentation, we foresee that the biomass will come from different sources and also from instrument sites from different industries. So of course, we are working with several. No, today might be getting confused. So, yeah, as I was mentioning in the presentation, we are always very interested in testing new biomass sources, because we also believe that it's a show that the biomass will come from different feedstocks. So we have been testing several different species, from Laminaria hyperborea to Tacarina latissima, Laria esculenta, sargassum, and we are in touch with several harvesters and cultivators from around the globe. And we do believe that there is potential for many different types of seaweed. We're also testing both brown seaweed and red seaweed. So of course, we are keen into testing more materials.
Okay. Thank you again, Camila. Next, we have Lauren. Lauren, would you like to hop in to ask your question?
Hiya, how's it going? Thanks so much for the talk. It's been great. I was just wondering, from an environmental side of things, where do you guys acquire most of the biomass? Like, is it cultivation or harvesting? Like, how do you make sure that those macroalgal environments are protected, rather than seeing like seaweed as a silver bullet, encouraging like sustainable harvesting or cultivation?
Yeah, I can answer that. So basically, we are using both type of biomass, both harvested and cultivated. We work very closely in R&D projects and product development projects with seaweed cultivators, basically also ensuring that the whole processing of the seaweed from the seedling stage to the final material is something that is sustainable and can be sustainably scaled up. Basically, that's why the LCA is very important. The one that Camila was showing is in the format of an article, published article as well, that has been done in collaboration with the University of Aalborg. And within our Eurostars project, we will be doing another LCA or updating the one we already have with an upscaled kind of production process. So basically, we partner up, as I think I mentioned before, with seaweed suppliers that can also show that they are consistent with sustainability, both on the harvesting side, since in Europe, basically most is being harvested at this moment, but also taking a look at the cultivated species and how this is also in monitoring how this is also impacting marine ecosystems.
That's great. Thank you, Adriana.
Great. Okay, next we have Oscar from Kenya. And yeah, Oscar, if you want to go ahead and ask us your questions, we're very interested to hear about your seaweed farm.
Thank you so much, and thank you for having this conversation. I think I came a bit late, and most of my questions seem to have been answered in the short time that I've been here. But it's exciting to hear that you're testing different species. Hopefully, you have something that we can grow here for, as a raw material for you. So my question would be, what are your contacts? Pick up the conversation offline.
Yeah, perfect. Then we can kind of talk separately and see how we can move forward, and also assessing your type of materials, Oscar.
Okay, great. Next we have Patricia. If you want to go ahead and ask us.
Hi, hello everyone. Thanks for the presentation. I was wondering if you're working on any IP, proprietary IP, if you have filed or you're in the process of filing any patent.
Yeah, that's part of our business model. So we want to be a technology provider. So yeah, of course, we work on IP, and we have IPs in progress on different technologies.
Thank you.
Okay, and then seems like we've come to our last question from Yue. Sorry if I'm not pronouncing that right. If you want to go ahead and ask us another question.
Maybe just a comment I see some more comment and question regarding mixing with plastic. I perfectly agree that mixing with high amount of other polymer which are considered plastic then make them clear plastic, but depends on the quantity you add. You are not considered plastic because it's just an additive. So our goal is to use our material, our material will be mainly based on seaweed polysaccharides, and that's how they will be. So there is a limiting amount that you can use other material and also you can use polymers which are not considered plastic as well. And that's what we do basically for the manufacturing.
Awesome. Okay, and then I'll go ahead and read Hiwei's question. So they're asking which seaweed shows thus far best quality for the company, and is there premium value for any?
This maybe, can you hear me?
Yes.
Yes, okay. As I answered before, there is not one seaweed which is the best. There is several factors that have to be taken in consideration. What are the final properties, or depending on the application you are developing, the price of the biomass for sure. So the main point at the moment is try to find like seaweed biomass that has a value that can be used for production of plastic with a competitive price. And then regarding the final properties, there are several, of course, depending on the type of seaweed, you have different property of the bioplastic, but that's where our expertise lies. With the formulation, you can basically tune into a wide spectrum of like mechanical and barrier properties. So I do believe that later on there for sure be some species that will be more adequate for some type of application, some other for others. But for the moment, basically we are testing different types, and I do believe there is space for all of them for different application in the plastic industry.
And if I may also answer one of the comments, I think it's important as well to understand, obviously that was from Philippe regarding NUTPLA or other competitors, if we can call ourselves competitors. I think competitors for us basically are more other material. We are like trying also to join efforts with other companies in the seaweed field to really make this happen. When it comes to material, it's very difficult to know because like no one has really reached the market or on larger scale, no one. Then after there's also some, like if we were comparing it, probably NUTPLA, it's more to them if they're in the call as well to answer, but probably they're working with brown seaweed as well. We work more with, as we said, side stream and also low refine because of the cost of the material as well, and that's maybe a bit more our specificity compared to the others that are more working with a very high refined product that are like either from cultivated species or from harvested species that are already available on the market. So that's a bit probably the difference as well, and the targets are probably different, the niche versus the scale that we want to achieve. So I would say that's probably one of the difference, and with others as well. Depending from its processability as well, how you can scale the product, how can you bring it as fast as possible, and using on the converter machine, so the speed of processing, and also behind the specification that we have, and we don't have any visibility on any of a seaweed startup to know exactly what are the specification when it comes to heat solubility that was mentioned, or compostability, or other OTR, WVTR, just to answer on that. But we are all working in the same direction, that's for sure.
Great, thank you, Guy. I see we still have a few more comments coming in the chat. Eric, if you'd like to just go ahead and ask us directly.
Okay, not really a question, but the comment is also in respect what you said about the market. What we have a cost seaweed network which is modeled towards Ulva sea lettuce as a model species. There are many companies active in that network, and the main conclusion, they're not really competitors. They do not consider themselves as competitors because the potential demand in the market is so large, and especially in Europe, that for now there is sufficient for everybody to grow. So there's a lot of sharing of information and data between these companies as well. So for now, it's really all peace and happiness in the market.
Okay. Oscar, you have another question?
Yes, please. There's all this talk about seaweed sequestering carbon and all those good things. I'm thinking if you're working with farmers or collectors from all over the world, then producing in one single space, is in that the transportation bit a bit controversial. Have you thought of maybe expanding in, say, in Africa, and happily welcome you in Kenya? Thank you.
Camila, we can't hear you.
Now, that's a very relevant point. And of course, we have been considering establishing the production close to the cultivation or biorefinery plant. This is what will make more sense. The main point is probably there regarding transplantation, the amount of water, because we know that seaweed, when it grows, is like 90% more of water. So depending on the amount of water you need into the biomass, then you will know how convenient it will be very close to the production and cultivation area or not. But of course, on the long term, for thinking about scaling up and thinking about the CO2 of the whole value chain, would probably make sense to have the production of the bioplastic close to the biorefinery plant.
Awesome. Thank you.
Great. So we still have a few minutes left. Does anyone else have any more questions or comments they'd like to ask? Okay, great. Well, then if there are no more questions, we are going to conclude today's workshop. So thank you so much again for joining. It was a real pleasure. And please stay updated with us on our further upcoming events and projects. And yes, also, if you would like the recording, please reach out to me and I would be happy to send it to you. Thank you, everyone. Have a great day.
Thanks,
Bye-bye.
Kara. Bye.
Thank you, Ziano. Thank you, everyone.
Thanks.
I think you need to stop the recording.
Will do.